Hey everybody, today I'm going to teach you a little bit about scientific notation in standard form called the dashed line method. So when you're writing a big number in scientific notation, the first number always has to be between 1 and 10. It can be 1, but it has to be less than 10. So I like to draw a dashed line after the first number I see. So I would do something like this, and that is where my new decimal point is going to go. So this number would now be 3.2 5, and I can ignore the other numbers because they have no value. Then you need to multiply by a power of 10. So I use times 10. Then to determine my exponent, I start at my dashed line and I always move to the current decimal in the number. So since this decimal is to the right, whenever you move right, you get bigger. So it's going to have a positive exponent. So I count the place values, 1, 2, 3, 4, 5, 6 place values. So my exponent is a positive 6. These two numbers are equivalent. If I wanted to go back to standard form and I was given the scientific notation of 3.25 times 10 to the 6th power, your exponent of a positive number tells you that you're going to have to move the decimal 6 place values to the right. So I would write 325. My decimal was here. Excuse me. I need to move it back 6 spots. 1, 2, 3, 4, 5, 6 is where my current decimal will be. You fill in your gaps with zeros, add your commas, and you notice that these two numbers are exactly the same. Let's do another example. This is another large number. It's going to have a positive exponent. I do my dashed line. So pause the video and see if your result will match mine. Did you write 8.1000016? You have to leave these zeros in because there are numbers behind it that have value. Times 10. And you counted the place value that you moved to the right, it's going to be a positive number, 1, 2, 3, 4, 5, 6, to the 6th power. To check your answer, you can rewrite your number in scientific notation and move it to standard form or standard notation by moving your decimal that many place values, 6 values, 2, 3, 4, 5, 6. So it would be this number. Go back and add your commas every 3. And they match. So these two numbers are equivalent. This is called scientific notation, and this number is called standard notation or standard form. Now what happens when you're working with fairly small numbers? The same rule applies. You go to the first number that has value, draw a dashed line, and your decimal point would then be there, 9.02. The numbers before the 9 do not have value, therefore you do not need to have it, and your number has to be between 1 and 10. Now in this case, you have to move to the left to get to the decimal. Whenever you move left on a number line, it's a negative exponent. So in this case, your times 10 will be to a negative exponent of 1, 2, 3. Again, it's a negative 3 because you had to move the decimal left. So it's like dividing by 10 by 10 by 10. So to check your answer, you can write your answer in scientific notation, converting it to standard form by moving it 3 place values to the left. Placeholder has to be before the decimal to protect it, and this is your value that you get. These two numbers are equivalent. One is called scientific notation, the other one is called standard form or standard notation. Do another one and pause the video here and see what you would do. Did you write your dashed line after the 9? So this number is 9. It is between 1 and 10, so you're so far so good. Times 10 to that, then you count how many place values to get to your original decimal. 1, 2, 3, 4, 5, 6. So this is your equivalent number in scientific notation. To get to standard form, whenever I see a negative exponent, I usually like writing on the right and then sticking my decimal where it is. I have to move it 6 values back. According to this exponent, it has a negative 6. I have to move to the left. 1, 2, 3, 4, 5, 6. Put your decimal, fill in your gaps with zeros, and then make sure you have a placeholder. So these two numbers are equivalent. Scientific notation and standard form. Working the other way, if you're given a scientific notation to go to standard form, you guys should be all able to do this by this point in your video. Positive exponent means you need to move to the right, so therefore I write my 3.2 on the far left. 1, 2, 3, 4, 5. Fill in your gaps with zeros, and then add your commas. So 320,000. And in this case, my exponent is a negative, so I have to move left. I always start over here. This is where it was. I have to move it 3 place values, 2, 3 to here, fill in my gaps with a placeholder and rewrite it to make it look a little neater. Those two are equivalent. This one's in standard form, or standard notation. This is scientific notation. One exponent to the left, that just means it's going to go right there, 0.167 or 167 thousandths. This number has an exponent that's positive, so I'm going to move to the right. 6 values, 1, 2, 3, 4, 5, 6. I have 2 places I have to fill in a 0. Then you go back and add your comma every 3. 5,600,900. In this case, your exponent is a 2, but this problem says correct the error. This number is technically incorrectly written. It is not in scientific notation because the first number is not between 1 and 10. So to fix this, you could either evaluate it this as is, because if I moved it 2 values to the right, it would be 36.7. Then ask yourself, well, how could I write that in scientific notation? It'd be 3.67 times 10 to the first power. Another way you can do it is say, well, to fix this, I have to move it 1 right. And if I move it 1 right, that means this number has to decrease by 1. So I subtract 2 from 1, 1 from 2, and I get 10 to the first power. So this is how you would correct the error. Thanks for your time, and I hope you enjoyed this little video. See you soon.